The platypus's combination of reptilian and mammalian qualities, such as the limited amount of yolk in eggs, as the offspring is nursed after hatching, and their body temperature, which is much lower than the average warm-blooded animal, led historic naturalists to view it as an ancient proto-mammal, skipped over by evolution, ready for extinction. However, despite these ancient characteristics, the platypus we know today is still a recent development from an order that used to be much more common. Monotremes branched early on in the mammalian tree. About 200 million years ago, around the late Triassic to early Jurassic period, the first fossil evidence of monotremes shows up. The first known monotreme is the Tianophilus trusleri, from the early Cretaceous period, about 130 million years ago. In the late Cretaceous period, the Steropodon gallimani would roam, and was likely much larger than the Tianophilus, and shows a much closer resemblance to what we now know as a monotreme today. Later in the Cretaceous period, the so-called Echidnapus would make its debut. Opalius splendens shows characteristics of both the echidna and platypus, placing its development before the major split between the platypus and echidna. Within the same geological area, many other monotremes would rule. One of the most significant is the Daharagara aurora, the earliest known distinct platypus of the monotreme line. Further in the future, about 60 million years ago, Monotrematum pseudoamericanum would roam South America, a large, ancient relative of the modern platypus. Soon, the Obdurodons would follow, living about 25 million years ago. Of the three known Obdurodons, Obdurodon dixconsi and Obdurodon tharluxschild would thrive in early Australia, growing much larger than the modern platypus and feasting on prey as large as turtles. The Obdurodon insignis remained a similar size to modern-day platypus and maintained many of the same characteristics we see today. This is reflective of its place as the most related to the modern platypus of the Obdurodons. Along the evolution of monotremes, a key characteristic is the seemingly sudden loss of teeth. Modern platypuses maintain one premolar and two molars as a juvenile, but as they age, they lose them, as the teeth are reabsorbed into the skull. Yet, the first monotremes, like Tianolophus and Steropodon, had 5 molars that they maintained throughout their life. Daharagara aurora and Parvolopolis clytie show a decline in the molars, only maintaining 3 throughout their life. Obdurodon shows yet another deviation. This platypus maintains 2 premolars and 3 molars throughout its life. These toothy ancestors likely had a diet of much larger, harder food than the modern platypus, such as fish, frogs, and even turtles. So how did the modern platypus end up losing its teeth? It's thought that a couple million years ago, the Australian water rat migrated from Papua New Guinea to the mainland of Australia. This invasion likely provided major competition over the ancient platypus's diet. To avoid the competition, these platypus ancestors would have changed their diet to the invertebrates that we now know them to eat today. This is what has led modern monotremes to lack the molars, as the hardy horny plates in their bills function much better to crunch up the insects. The evolutionary history of platypus still leaves a lot of space for new information. As new fossils surface, views may change on the exact evolution of the modern platypus. But regardless of the result, it will always be the strangest mammal in our world.